Welcome to class, everyone. I am so thrilled you're here with us today for this explainer because, well, we're going to decode the secret physics hidden right in front of you, literally in your everyday life. Today, we're talking about describing the motion around us, and I promise, by the time we're done, you'll never look at a moving car or a spinning wheel the exact same way again.
But hey, before we get into the heavy lifting, I actually want to start off with a question. Are you actually sitting perfectly still right now? I mean, really think about it. You might feel like you're glued to your chair, completely motionless, right? Well, as we're going to see today, motion depends entirely on how we look at it. Okay, let's dive right in.
All right, here is our lesson plan for today. We've got 4 foundational concepts to cover. 1. Describing position and reference. 2. Rest versus motion. 3. The 3 types of motion. And finally, number 4, moving in a straight line.
So, let's kick things off with Section 1, Describing Position and Reference, Finding Our Starting Point.
Think of physics a bit like a detective story. To solve any mystery, you've got to have a solid starting clue. So here is the absolute golden rule of our lesson today. To describe the position of an object, we must first specify a fixed point. We call this the reference point. You might want to jot that down in your mental notes, because without a fixed point, trying to describe where something is becomes, well, quite literally impossible.
What's really fascinating, though, is just how familiar this concept actually is to all of us. Think about opening a GPS app on your phone. You type in where you want to go, sure, but the app can't actually do anything until it drops that little map pin right where you currently are. That pin, that's your reference point. Everything else is measured relative to that single fixed spot.
Let's look at another really common everyday example. Imagine you're standing right by a row of green trees on the side of the road, and you're watching a red car drive past. Now, to actually prove that the car is moving, you need a fixed point. In this scenario, either you, the observer, or those firmly planted trees serve as that reference point. The car is changing its position relative to the trees, so boom, we know it's in motion.
All right, moving on to Section 2, Rest versus Motion, a matter of perspective.
Now, we are about to look at a seriously mind-bending idea in physics. The idea that an object can actually have 2 completely different states of motion at the exact same time. So here's a riddle for you. Can you be moving and standing still at the exact same moment? I'll give you a second to think about that impossible-sounding paradox. Sounds like a total trick question, right? But the answer is actually a resounding yes.
And this perfectly illustrates exactly why that is. Let's use your morning commute as an analogy. When you are sitting in your car, driving down the highway, you are entirely at rest compared to your car seat and your seatbelt. Your distance from the dashboard? It's not changing at all. But at the exact same moment, you are in motion compared to the trees and the road passing by outside at, say, 60 miles per hour. It's wild, right? It all depends entirely on your reference point. Which brings us to Section 3. The 3 types of motion, categorizing our world.
By the end of this section, you are going to be able to categorize every single moving thing you see into one of 3 simple buckets: translational motion, rotational motion, and oscillatory motion. Now, please don't let those scientific terms intimidate you. I promise they are really just fancy physics words for things you already see every single day. Let's break them down.
First up on the list is translational motion. This is simply the straight-ahead, everyday zoom of a car cruising down the highway. The entire object moves from point A to point B in space. Basically, when you walk down the hall or a train rolls down the tracks, that is translational motion.
Next up, we have rotational motion. Think of a bicycle wheel. Rotational motion is exactly what it sounds like. It's movement spinning around a central, fixed axis. The wheel itself isn't necessarily moving from point A to point B in this specific context, but it is turning round and round its center.
And our third and final bucket is oscillatory motion. This one is defined by a back and forth rhythm. Think of the really soothing, repeating swing of a grandfather clock's pendulum. It passes through a central point, goes to one side, comes right back, and repeats. Classic oscillatory motion.
And that leads us into Section 4, moving in a straight line. Linear motion demystified.
So we're going to zoom in on one very specific, very common type of movement. Here is the textbook definition, and honestly it's incredibly simple and direct. Linear motion is when an object moves in a straight line. If you slide a book across a flat table, that's linear motion. But I actually want to challenge your default assumptions about what a straight line truly looks like out in the wild.
So the really crucial point here is this question. Does a straight line always have to be horizontal? See, when we hear the phrase straight line, our brains usually default to a flat road, or maybe a ruler sitting on a desk. But physics? Physics isn't just about flat surfaces.
For instance, think about Olympic swimmers racing across a pool. They are moving in a horizontal straight line. But if you take a blue ball and drop it so it falls straight down, well, that is a vertical straight line. Both are perfectly straight, they just travel in completely different directions.
So here is the big takeaway from this part. A straight line equals linear motion, no matter the direction, whether it's side to side, straight up and down, or hey, even diagonal. If the path doesn't curve, it probably earns the title of linear motion.
Class, you have done fantastic today. We've decoded position, we've tackled the paradox of resting while moving, and we've sorted the world's motion into neat little buckets. But before I let you go, I want to leave you with one final thought. As you walk out of this lesson and go about your daily life, what is your reference point for the rest of the day? Challenge yourself to look at the world just a little